Welcome back. Don't forget to subscribe and follow our YouTube channel for new updates and new videos. Okay, let's look at scalar multiplication. This does exist in vectors, but we need to ask ourselves, what is a scalar? A scalar can be a quantity, but from our simple physics, scalar quantities have got only one quantity, and that is called size or magnitude. So scalar quantities have only got magnitude. So if they've only got magnitude, we are going to look at the multiplication in vectors. But in vectors, multiplication only happens when we are multiplying with a scalar. So a scalar is a value that will multiply the vector in all its compositions. Now, what does this give us? We can have vector OP given as x, y. But the moment we need a scalar, we can say OP. What if they tell us to get 2 OP? So 2 OP will be 2 multiplied x, y, which is our vector. So when we are to multiply or when we are to analyze this OP represents a vector. But this number 2, what we look at as the coefficient of the vector, is not representing the vector, but it is a scalar. It does multiply within the components of the vector. So 2 OP can be given as 2x, then 2y. Please don't divide our students. We leave the answer like that. So what does this mean? We brought OP and we used OP to find 2 OP. So we can use it also to find 3 OP. And this will be 3 times the initial OP, which is xy. And so 3 OP will be 3x, then 3y. This is when we multiply with the scalar. Scalar multiplication does change the composition, no. But we do multiply and it affects in increasing the size. It does not change the direction of the vector, but it can increase the size of the vector. That is when we multiply using the scalar. So from scalar multiplication, we can look at different forms and then we can look at different examples. For instance, we can be given an example and it says, given that OP is equal to 2, 8, and OQ is equal to 1, negative 2. Find Roman 1, they say 2 OP. Roman 2, they say 3 OQ minus 2 OP. That can be our simple example. So from our simple example, given that OP is 2, 8 and OQ is 1, negative 2, find Roman 1 is 2 OP. Roman 2 is 3 OQ minus 2 OP. So this is always very simple. We can find 2 OP, and so we can say 2 OP is given as 2 times the value of OP. So when we look into our question, OP is 2, 8. So when we multiply here, the result is going to be, we don't divide vectors, we just multiply and get the value of each coordinate. So 2 times 2, we are going to get a 4, and 2 times 8, we shall get a 16. So this 16 is the value of 2 OP. So this answers our Roman 1. That is the answer to Roman 1. Then we can go and look at Roman 2, which says 3 OQ minus 2 OP. So when we look at this in the question, we already have 2 OP in our question. So we are going to concentrate on finding 3 OP first. So we are going to say this is the same as 3 into. So we look at OQ, which is 1, negative 2, then minus 2 OP, which is given initially as 4, 16. We've already got that. So we come and look at this as a 3, a minus 6, then minus 4, and a 16. So we can easily simplify and say 3 minus 4. Our answer will be minus 1, minus 6, minus 16. Our answer will be a minus 22. So this becomes the value or the answer to Roman 2.